Hi class, this is Professor Smith. I'll be doing a movie on hypothesis test, population standard deviation, and variance. First, let's begin by reviewing the 5 steps to hypothesis testing. The first step is to determine the null and the alternative hypothesis, and then the next step is to determine the distribution, and then the test statistic, and then we want to make a decision and summarize the conclusion. So consider the following hypothesis tests for the population standard deviation and variance. The records show that the lifetime of electric bulbs manufactured in the past by big corporations have a mean of 9330 hours and a standard deviation of 128. The corporation claims that the current standard deviation, sigma, is less than 128 following some adjustments in the production unit. A random sample of 26 bulbs from the current production lot have a mean lifetime of 9331 hours with a standard deviation of 103. Assume that the lifetimes of recently manufactured bulbs are approximately normal. Is there enough evidence to conclude at the 0.05 level of significance what the corporation's claim, that the corporation's claim is valid? So we're going to start off with the first step, which is the null and alternative hypothesis. So in the past, big corporations had a mean of 9330 hours and a standard deviation of 128. And then the corp claims that the current standard deviation sigma is less than 128. So this first English statement had a mean of 9330 and a standard deviation of 128. We're going to rewrite that had a standard deviation of 128 as the standard deviation equals 128. And so because the equality symbol is always tied to the null hypothesis, because the null hypothesis assumes nothing's changed, it assumes innocence like our court system, and therefore status quo. So we always attribute any mathematical statement that has either the equal sign or the less than or equal sign or the greater than or equal sign, that's going to be represented in the null hypothesis. So we're saying the standard deviation, sigma, is equal to 128. Then here it states that they claim that the current standard deviation is less than 128. So the less than would represent the alternative hypothesis. So we're going to have sigma less than 128. And right now I'm using equation editor and that, math type. And math types gives you the ability to type in mathematical symbols. And this one we'll just grab from the keyboard. And so it turns out, since this is the one that's tied to the significance level, that the standard deviation is less than 128, I always like to add this other feature by stating that this is the claim. So I'm going to type right here the word claim. The claim is sometimes the alternative, is most often the alternative hypothesis, but not always. And so we always look for that statement that talks about at what significance level. So let me go back out to the original problem so you can see what I'm referring to. So here it asks the question, is there enough evidence to conclude at the 0.05 level of significance that the corporation's claim is valid? And the corporation claimed that the standard deviation is less than 128. I also like to include the significance level. And so they want us to test this claim at the 0.05 level of significance. So I like to type it right here in that first step where I write down the null and alternative hypothesis. So now we have it. Now let's go on to step 2. Step 2 is where we determine the distribution. And it turns out whenever we're doing a hypothesis test about the population standard deviation or the population variance, it turns out we're always going to use the chi-squared distribution. And so what I'd like to do is also remind you that with the chi-squared distribution, that's the one that's right-tailed, and the degrees of freedom is always the sample size less 1. So let's review again what's the notation for the standard deviation. So it turns out when we're finding the test statistic, we do need to recognize that little piece. And one of the pieces that we need to know is the symbol for the population standard deviation, which is sigma, the Greek letter S, lowercase s, and variance, which is sigma squared. And then for the sample standard deviation, it's S, and for the sample variance, it's S squared. So it turns out the test statistic for hypothesis test on the population standard deviation or population variance is given by chi-squared equal to n minus 1 S squared over sigma squared. So let's go back out to our problem and determine what S and sigma are, since this particular problem was a hypothesis test about sigma being equal to 128 or less than 128. And so what I'm going to do is I'm going to replace the sigma that's in the denominator with 128. And since sigma is equal to 128, I've got to be sure that I square it. Now, if they had told me that sigma squared was 128, I wouldn't need to square it. And then n represents the sample size. And so remember that n minus 1, which is the degrees of freedom, is also going to be the top part when we're computing the test statistic. So let's go back out to our problem to see what the sample size was. So it says here we had a random sample of 26 bulbs from our current production lot. It gave us the mean lifetime, and it also gave us the standard deviation of 103. It tells us that it's normally distributed, and therefore that's why we know that we can use the chi-squared distribution. Actually, because it's also a test about the standard deviation and the population variance, or the population variance. And we know we're going to use chi-squared. All right, so then let's go out and let's go out and compute the test statistic. So we're going to type in 26 minus 1, which is 25, times 103 squared. And that will give us the value of the test statistic. So let's go out to the ALEKS calculator and find out that value. All right, so now I've opened up ALEKS, and we'll go ahead and select the calculator. And so it was 25 times S squared, which was 103, and X squared, divided by 128 squared. And again, remember, if they gave you the variance was 128, that means sigma squared equals 128. You would not have to square it. But in our particular problem, we had that sigma was equal to 128 from the null hypothesis. So let's go back out and evaluate that. And so for our test statistic, we get 16.188. And you usually want you to round it to 3 decimal places. So that's equal to 16.188. It's actually approximately equal to. So the next step after we compute the test statistic is to make a decision. And turns out the decision is to reject H0 in favor of H1 if the test statistic is in the critical region. So let's just go out and capture what it means to be in the critical region. So now we have a visual of the chi-square distribution. Remember, it's right-tailed, and the degrees of freedom in this particular case is 25. And we now need to figure out, well, what's the value of the chi-square distribution, of the chi-square value, what is the value of chi-squared such that this region here is where I think, my goodness, it's really far away from the null hypothesis, which assumes that it's equal to 128. And it turns out in order to find this critical region, what we need to know is this area here. And it turns out that's our level of significance. And our level of significance, if we go back to the null hypothesis, we had that our level of significance was 0.05. And you say, well, how do you know that it's to the left and not to the right? Well, if we go back again to the null hypothesis, the fact that we had less than 128, the question then becomes, well, how far less than 128 does it have to be? And that's what that 0.05 is. It lets us know there's a 5% chance that we might reject H0 in favor of H1, even though H0 is true, even though we could be making a mistake. And so that 0.05 is going to be in the left tail. Now, if the alternative hypothesis was greater than, then it turns out that rejection region would be to the right. And if the alternative hypothesis was not equal to, then you would have two critical regions. One to the left, because there's two ways to not be equal to 128. One way is to be less than 128. The other way is to be greater than. So in this particular case, since it's a left tail test, because of this less than symbol, we know that the area on the left of the tail is 0.05. So if we go out to the ALEKS calculator, it will help us find the value of chi-squared. It does it using chi-squared box. And chi-squared box on the ALEKS calculator says, if you give me the area to the right underneath the curve, I will give you the chi-squared value. So let's go out to the ALEKS calculator to determine that critical value. And so if we select chi-squared, so if we select chi-squared on the ALEKS calculator of 0.05, that would give us, if we wanted the area to the right to be 0.05, in our particular case, the area is going to be 0.95. And so we get a cutoff value of 14.611. So this value here is 14.611. So that's our cutoff value. And it turns out our test statistic was given by 16.188. And that guy is going to fall to the right. So maybe right about, maybe there. So we can clearly see that this value here is not in the critical region. So then our decision would be, do not reject H0, not in favor of H1. So let me write that down. So otherwise we're going to say, do not reject H0, and therefore I'm not in favor of H1. So then our next step is to summarize our conclusion. So there is not enough evidence, because remember we said here we're not in favor of H1, not in favor of H1. H1 was the claim that it was less than. So there's not enough evidence to support the claim at the 0.05 level of significance that the standard deviation has decreased. And so if they ask the question, is there enough evidence to support the claim that it's decreased? No, there's not enough evidence to support that claim. So the answer would be no. All right, well, thank you so much. I hope this movie was helpful, or is helpful. If you have any questions, feel free to call me at 916-813-9027.